Did we define what is the definition of bounded sequence? In the last lecture we did, if a sequence is convergent then it is having a unique limit. Yeah, monotonic, we have defined monotonic, increasing, decreasing. Yeah, and bounded. Yes, yes. This one definition is much proper one. That is, a sequence xn is bounded if there exists a number m such that mod of xn is less than equal to m. Perfect for all natural numbers, for all n. So this is what I want to use here. This is what I want to prove. Correct? The question given here is every convergence sequence. So let us start. Let xn converge to x. Can somebody tell me the definition? What is the definition of xn converge to x? Epsilon delta definition. I think now you should answer this part. Let's start with, for all epsilon positive there exist, yes, okay, correct, for all n that is greater than equal to n naught it is satisfying some condition. Okay, I'll just write this part here. um, what is the condition? Xn minus x must be less than epsilon for all n that is greater than equal to n naught. Perfect. Is that clear? This is the definition. But do you observe something? What this definition says, this inequality is true for all n which are greater than n naught. That means what? As per the graph we have seen, that is n naught will be somewhere here and your epsilon band will be somewhere here. Correct? Here will be your x. This is x minus epsilon, x plus xn minus epsilon, x. Yeah, x minus epsilon, x plus epsilon. Yes. And what we said here, it will be something, and after and not everybody will be in this epsilon band. This was the definition, correct? Okay. Now what do I want to prove? I want to prove this sequence is bounded. That means what? I want to have xn, mod xn, that must be less than something, correct? So how should I start with? Can somebody write consider mod xn? Can I relate with something? I have given xn minus x that is less than epsilon, correct? And can I relate this thing with this? And if yes, then how can I do that? Yes? If it was xn minus x, then I could have written it as less than epsilon, correct? So what I should do, I should write it as xn minus x plus x. Can I do that? Yes, can I do that? Now what? Can I use triangle inequality? This is less than equal to mod of xn minus x plus mod x, correct? And what else? Now can I write this as, this is less than xn minus x is less than epsilon, so this is less than epsilon plus mod x. Since the sequence is convergent, I can choose any value of epsilon. I don't need to prove for everybody. I need a number, correct? So what I will do, I will choose for epsilon equal to 1. So for epsilon equal to 1, this is I am having. So here also, since it was true for every epsilon, I choose a particular epsilon. So this xn minus x, that will be less than 1. Here also this will be less than 1, correct? So this is 1 plus mod x. Do you see this is a number? X is already a number. It is not depending on your natural number n, correct? And this is 1 plus mod x. So mod of xn is less than 1 plus mod x for all n greater than equal to n naught. Did we prove that mod xn is less than a number for all n. Are we done? Are the proof is the proof complete? We wanted to prove every convergence sequence is bounded. That means what? We wanted to prove mod xn that is less than some number m. So did we prove now? Yes, anyone? In the starting only I gave you some hint. Till now we have proved mod xn that is less than 1 plus mod x, but for which n? All the n which are greater than n naught, all this type of n. So what are remaining now? What is remaining now to us? The remaining people is this one, up to n naught. 1, 2, 3, up to n naught, what happened to them? But up to n naught they are finite set, correct? If you are having any finite set, can you get the minimum or maximum? You don't have to struggle in that, correct? Suppose you are having 10 people, so you can clearly choose who is minimum or who is maximum. Yes, so what else you should do now? You should write let m is equal to maximum of x1, x2 up to x n naught minus 1 and 1 plus mod x. Okay, so you are choosing m is equal to maximum of these many people, correct, where x1 x2 up to this, these are finite sets, so I can take maximum, and this is I am having bound by using epsilon delta definition. So can I write this as mod xn that is less than m? Yes, and this is true for all n belongs to natural number. Can I see that? What that imply? That is xn is bounded. Did I prove? Yes, tell me first. Did I prove this? Let us quickly go through the proof. We were given xn is convergence sequence and we need to prove xn is bounded. So I started with, since xn is convergence, so for every epsilon this is true. So I am particularly choosing for epsilon equal to 1, there should exist an n naught belongs to natural number such that mod of xn minus x that is less than 1 for all n greater than equal to n naught. And now I am having mod of xn that is equal to mod of xn minus x plus x that is less than equal to, by using triangle inequality, that is less than equal to mod xn minus x plus mod x, and mod xn is less than 1 plus mod x. And let m is equal to maximum. Why I am choosing maximum like this? Why these many people? Because these were not included in this 1 plus mod x. In 1 plus mod x bound, this is a number only. In this we were considering all n which are greater than n naught. So what about up to n naught? They are remaining. They are remaining to have a bound. There may be a person who is here. There may be a person who is here. Then my bound will be that one. Correct? So that's why we have to take them also into the consideration. So we started with let m is equal to maximum of this, and then mod xn is less than m, then hence prove. Yeah, correct. Is the proof clear to you? If you want me to repeat, I can. Just tell me fast. Yeah, okay. So we have done two theorem, that is first is uniqueness and second is this. Okay, now let us see the algebra of sequences. What do you mean by algebra of convergence sequence? That is following we are going to prove. The first one is if xn converges to x, then I think I should start with yeah, that is fine. If xn converges to x, then prove mod xn is converged to mod x. This is the first one we want to prove, and the second one is hmm, if xn converges to 0 if and only if mod xn converges to 0. Okay, observe something, this is just then and this is if and only if. And third case, if you are having, if for the third one I'll write something, if xn converges to x and yn converges to y, where y is then the first one I want to prove xn plus yn that converges to x plus y, and second सेम प्लस की जगह पे माइनस लिया देन ऑल्सो इट शुड बी ट्रू x and minus y and that is converts to x minus y. So but I'll not do here. I'll do one more thing, that is alpha is a real number, then alpha xn converts to alpha x. Okay, the second one. The third one is xn into yn multiplication that converts to x into y. And the fourth one, if your y is non-zero, then xn upon yn that converts to x upon y. This should even yn should also non-zero. So yn and y should be non-zero. Then xn upon xn that converts to x on y. This is called algebra of sequences. Okay, just try to see first what we are doing. The first one is if xn converges to x, I want to prove mod xn that is converges to mod x, and that is true from your unit 1. If you have done unit 1 properly, then you'll see this is absolutely true. Second one is it follows from this only. And third one xn plus y, and here we are having two people, so we'll see one technique how to do how to deal with these type of sequence when you are having two sequences together. How can we conclude there, correct? So let us start with the first one. Yeah, what is you are given with? You are given with xn converges to x, so you'll write definition here to prove mod xn converges to mod x, correct? So to prove mod xn converges to mod x, what you should consider with? Main thing is this consideration part. You should consider with mod of mod xn minus mod x. Right? And let me write the definition. For all epsilon positive, there exists n naught belongs to natural number such that mod xn minus x this is less than epsilon for all n greater than equal to n naught. Correct? This is the definition. To prove mod xn converges to mod x, I have to start with mod of mod xn minus mod x. And in your unit 1, did you prove these type of sequence they are less than equal to something? In your unit 1, did you prove something? These type of sequence they are less than mod of xn minus x. Did you prove that? Just recall. If you don't remember, then you go back and see that we have proved this thing is less than equal to mod of xn minus x, and if this is less than mod x, so that is less than epsilon. That means what we have proved? We have proved this mod of mod xn minus mod x that is less than epsilon for all n greater than equal to n naught. That means what? Mod xn converges to x, mod x, hence proved. Correct? With this inequality, everything follows. Yes, is that clear to you? Hello. This was the first one. What about the second one? Now we have already proved. Second one is xn converges to x if and only if mod x, sorry, xn converges to 0, no? If and only mod xn converges to 0. So one way is already proved, that is from 1 xn converges to 0 imply mod xn converges to 0. Now to prove, now we have to prove mod xn converges to 0, this is given to us, and to prove xn converges to 0. That means what, mod xn is converging to 0. What do you mean by that? For all epsilon positive, there exists n naught belongs to natural number such that mod of mod xn minus 0, that is less than epsilon for all n greater than equal to n naught. But what is mod of mod xn? This is again, forget about 0. This is same as mod xn, na? Mod of mod xn, since mod xn is positive number, so that mod will go away, so we are having mod xn minus epsilon for all n greater than equal to n naught. And what is mod xn? You can write it as xn minus 0, that is less than epsilon for all n greater than equal to n naught. What this implies? This implies that xn converges to 0. Hence proved. We started with mod xn converges to 0, we proved xn, hence proved. Is the proof clear to you? This was 1 and 2. Now for the this algebra, I'll just tell you one technique here. Uh, just go through the proof once again and see if you have any doubt. Otherwise, we'll start now. The next part. Even the fourth one, I can reframe it as I don't have to prove for everybody. I'll just prove for this. I just prove for 1 upon y and 1 upon y. That's it. And I'll use from the previous one, I'll prove xn upon y and that converts to x upon y. I don't have to write it in, so I'll write fifth one as xn upon y and converts to x upon y. Fourth, once we prove fourth one, fifth will follow. Okay, so shall we start now? So what is the strategy now? First of all, see, here you are given xn converts to x, here you are given yn converts to y. You want to prove this part converts to this part. That means what you start with, consider क्या करना है तुमको? You should consider mod of xn plus yn minus x plus y, and you need to prove that part is, I'll write. See, first one, you are given xn converts to x, yn converts to y. So to prove xn plus yn converts to x plus y, I'll leave some spaces. I'll tell you what to prove this thing, what I should consider. I should consider, consideration part should be the last one. I should consider xn plus yn minus x plus y. Do you agree? And we want to prove this is, if I prove this is less than epsilon, that means we are xn plus yn converts to x plus y. That's it. So this is what I want to consider. Yes. So you are given xn converts to x, yn converts to y. You just write the definition of xn converts to x, write the definition of yn converts to y. That means for given epsilon positive, here you will be, there will exist n1 belongs to natural number. Since you will be having 2n, so I will write there exists n1 belongs to natural number such that mod xn minus x, that is less than epsilon for all n greater than equal to n1. And for the same epsilon, for same epsilon I want to write there exists n2 belongs to natural number such that mod of yn minus y that is less than epsilon for all n greater than equal to n2. Yes, can you see it graphically? Once you see, then you'll realize that will prove quickly. See, your x is here. X, I'll be having an epsilon band for x, correct? And y will be somewhere. Suppose I'm considering y is here, so I'll be having a epsilon band for this, correct? And suppose for x, I am having n1 here, so I'll just write it with different color. That means after this n1 everybody is in this epsilon band, okay, for x. And let me write n2 here, suppose, and just change the color. That means what? After this n2 everybody lies in epsilon y epsilon band, correct? So that means it will also start from here, here, something like that. But after n2 everybody in this band, correct? So I'll just do one more thing. I'll just draw a line here. This is the border for me for n2, and for I do it with the black for n1, correct? Okay, yeah. So do you understand? जो भी मैंने लिखा है, I'm just drawing it properly. That's it. Now my question is that can I choose out of these n1 and n2? Can I choose a n which will ensure me that everybody will lie in that epsilon band? Which n should I choose so that everybody should lie in that epsilon 1? Can I choose n1 such that both the people are lying in epsilon band? If I choose n1 as my final one, then my xn is lying in my epsilon band. That is perfectly alright. But what about yn? Yn is not lying in epsilon band. Do you see? There are some people which are lying behind that. Correct? So my question is, can I choose n2 now? Let us see. If I choose n2, then my xn, all the people xn, they are lying in epsilon band. What about yn? They are also lying in the epsilon band. Do you see? So which n should I choose so that both the things should satisfy? I'll explain you once again. In the first case, I am saying this n1 is for x. That means everybody lie in this epsilon band after n1. So after n1, for x, everybody is lying this epsilon band. And for n2, everybody of yn, they are lying in epsilon band. That means after n2. But I want to choose a n. I want to choose a single n. I'll name that as n0, such that both the things should satisfy. Correct? So what I will, I'll think I'm having two people, so let us select one of them. So I'll see, suppose n1, can I do with n1? If I choose n1 as that one, see, my n1 is here. So my question was, everybody should be in epsilon band, whether it is xn, whether it is yn. But if I choose n1, after n1, xn is lying in epsilon band. That is perfectly alright. But yn is not. There are some term of yn which are not lying in epsilon band. So I cannot choose n1. Correct? So n1 is cancelled. Can I choose n2? Let us see. After n2, as per the definition, everybody of yn, they are already in epsilon band. And you can see n1, which is n2 is greater than n1. So all the terms of sequence xn, they are also lying in epsilon band after n2. So if we choose maximum of n1 and n2, then our result will hold. Do you agree? Choose n not equal to maximum. See, as per the drawing, I drawn x का term यहाँ पे, y का term this में shuffle, correct? So I should write n not equal to maximum of x.